So we are now live on YouTube. Not live, but we'll be on YouTube later. I'm free to share that story to whoever. Yeah, I mean it's so Kalhaku told me a story by email of um, kind of relevant to Homework 11. He was driving down a very steep, very long road in Colorado, coming into Denver, in a truck towing a trailer, and it turned out that the truck's brakes were able to absorb heat without heating up better than the trailer's brakes. At least this is what my best guess is. And the trailer's brakes wound up heating up and losing their ability to cause friction. Um, so the trailer was unable to slow itself down. The only thing slowing it down was the tow bar from the truck, which made it fishtail back and forth. And he said it was terrifying coming down this road with this trailer that had, the brakes weren't working as well as they should. So today is kind of an interlude. We've always done kind of interlude classes between units. I see a couple of people are still joining. Um, a lot of you have been asking me about the paper. Um, Today is where we assign the paper for real. So today is where we talk about what your paper will be, where I share the assignment. It's been posted on the course website, and go into depth about what you will be doing. Just as a note, anybody who does not have a link to the PDFs of the slides is here. So this is what I'm showing here. As always, I'm going to take whatever I scribble on this and post it on the website. Um, we're also going to talk about exam 3. Um, we're also going to circle back to a very common question that people asked in the survey at the beginning of the semester. A lot of people wanted to know about black holes and how they worked. And a lot of people wanted to know about the really cool picture of a black hole that we took using an instrument called the Event Horizon Telescope. So we're going to talk about how that was done. This people probably remember this super famous image from last year. Um, this is the first ever real picture of a black hole, and this was done last year by a fantastic collaboration of folks, and we'll talk about how that was done. So we're still grading your exam. It's taking a little bit longer to grade online than it takes to grade paper exams just because Blackboard is sometimes slow. I'll be generous. Um, so if a couple of things about that. If you were unable to turn in your exam for some reason, if something went wrong on Blackboard, a lot of people contacted me and said something went wrong when I was submitting my exam. Help! Oh no, what do I do? And we worked with you. But if you still have not turned in your exam, or if there's something going wrong, please send me a note very soon. We need to get your exams in. Um, we will work with you, whatever's going on. Just let us know. Also, if you sent me some mail that needs a response in the last few days, um, please let me know. I know that there are some folks who would like kind of a, please calculate my grade for me ahead of the pass fail deadline, which is April 10th. We can't calculate everybody's grade for them. Um, but I can send you out some advice for making decisions about whether or not to switch to taking the class pass fail. The short version is that you should only do that if you feel like you're in a position where you have a super high GPA and this class's grade, like a passing grade you get in this class, will likely be lower than um, a super high GPA you have. And I don't think that many people are in that boat because the grades for this class are honestly going to be really good. Like probably like half the class is going to get A's and A minuses. Um, might not be quite that high, but yeah, the median is going to be B plus or A minus this semester. We're pretty sure. This exam is no exception. So we haven't finished grading everything, but what we have looked at so far, people are doing real well. There are going to be a lot of A's on this exam. Um, are there any other comments about how exam 3 went? Nicholas, So the grading scale, I'll just write it on this slide. So an A, not an A minus, is an 88. An A minus is an 80. A B plus is a 75. A B is a 70. A B minus is a 65. A C plus is a 62. A C is a 58. A C minus is a 55. A D is a 50. So that's the grading scheme. Keep in mind that exam grades tend to run a little bit lower than other things. Like homework is kind of free points. Coming to recitation is kind of free points. Um, so, if you got like a 70% on the exam, well, that's a B. And it's quite likely that you're going to get a B plus, or even an A minus once you add in all of the stuff that tend to run higher than the exams. Does that answer your question, Nicholas? All right. Will you be able to see what your current grade is in the class before the semester ends? Not directly, because it requires a lot of calculation, and we often put our effort into teaching rather than into calculating grades before the end of the term. But you can estimate it because a good way to estimate your exam scores or your grade will be to, as Cooper says, we drop your lowest exam grade. So take your two highest exam grades, um, average those together, and then if you've been keeping up on the homework, um, homework counts a little bit more than any single exam. So if you've been keeping up with the homework, keeping up with, going to recitation, your overall grade, you may be like one letter subgrade above the average of your two highest exams. So if you want to estimate your grade in a really crude way, and this is what I do when I like get mid semester transfer forms and I have to like estimate a student's grade, is I just average your highest two exam grades, and then if that's a B, then I write down B plus because people tend to run about one letter subgrade above that. Yes, it is just the final coming up. The final will be the same format as what you just did. It'll be 24 hours. Um, you can use your notes. You can use all your stuff. Unless you all send me feedback telling me that that doesn't work for you, that's what we will do. Um, so just as a reminder, this is a tough time for everybody. You all just had an exam. Exams are really tough. I've gotten a lot of feedback from students saying, this is really stressful. Not this class specifically, but this whole online teaching stuff is tough. And just a reminder that we're on your side, that we do not want to add stress to your lives right now. We do want you to learn as much physics as you can, as you have, mental space for, as you have energy for. We want to be here for you if what you want to do in these weeks is learn physics. Um, we want you to learn physics without having to do a bunch of busy work. So we're trying to keep the things that you do for our class actually useful. We're also trying to help support everybody in what's a challenging time for everybody. Um, you all can support each other, but we have special things we can do as faculty and as your instructors to make sure you get support. Um, and finally, we want to make sure that everybody is treated with respect in this class, and in all of your classes, and in the whole university. So if there's anything that we need to do to ensure that all of these things happen, please drop us a line. You can contact me over Discord, by email, um, any other means, and we will make sure that you get what you need. Um, So the next thing that I wanted to talk about was the process of science material, like what we had planned to do for today. But are there any questions about how the rest of the semester is going to go? Anything anybody wants to talk about? All right, if there's nothing anybody wants to talk about, let's move on to the main topics for today. So, last Thursday, we had a half of a class where we talked about what science was. We talked about why science is a powerful way to learn about our world. And we talked about mostly that the scientific method is a series of safeguards designed to help us avoid fooling ourselves. And I think this is kind of a crucial point that people have always been very, very clever. Well before the development of the scientific method, human beings were just as smart as they are now. And nothing happened with the emergence of modern science that made us all that much better at discovering things. But what the scientific method enables us to do is avoid getting fooled in ways that we were not able to do as well before. Um, and so you can think of the scientific method as safeguards to stop us from getting fooled. And today we're going to talk about ways that those safeguards can either be accidentally, by mistake, or deliberately circumvented to result in getting incorrect conclusions. And other sorts of related abuses of the scientific process, because that's what your paper is about. Your paper is about um, a case study on science done badly. I want to make a couple of notes before we start here. Um, One of them is that when we say scientific integrity, we don't mean the usual sort of integrity. We don't mean the sort of integrity that means that you take your take home exam honestly without asking other people to do it for you on Chegg. We don't mean the sort of integrity where you don't steal things from people. Those are very important, right? Those are part of being a good, honest person. But that sort of ethics is not what we're talking about. Um, it's possible to do like really awful things in the process of doing scientific research, but still for the conclusions of that research to be well grounded and like the conclusions to be valid. So Nicholas has given an example, sending monkeys to space. And Brian mentions the Russians sending Laika, the dog, to space. So you're using this as an example of um, perhaps cruelty to animals. Does anybody have any other um, favorite examples of this? Yes, people are talking about animal research in general, which they're saying is in their view not ethical. Um, a lot of any examples of this that anybody else wants to think of? I want to hear a lot of your comments today in class. Samuel, what do you mean by research on twins? Do you have a particular example of twin studies that are deeply unethical? Um, so Megan mentions paying humans to be research subjects. Yes, if that research harms the people involved, then yes, there are some very real ethical concerns there. But it turns out that paying people to be part of your studies can also lead you to get incorrect conclusions. It turns out it kind of is both unethical and bad science unless you are very careful. Um, yeah, Samuel mentions this idea of separating identical twins at birth, um, not for their benefit. Um, yeah, so the everyone's talking about human research, human subjects research, and this is a huge minefield, right? Because you want to learn something, but you also want to make sure that the people that are part of your study are supported and aren't harmed and are better off because of it. Ryan's example, the Nazi experiments, is a really good example. The Nazis did a lot of things that was founded on like bad science. Their ideas about people of different ethnicities were, they are an example of the flawed science process we will talk about. Um, but they also did some research on prisoners that it turns out drew correct conclusions, even though it often killed people. Like it's deeply unethical, profoundly harmful, utterly awful things to do, but didn't necessarily result in drawing wrong conclusions. Um, Jacob mentions clinical trials of drugs where these trials are blinded, where some people get a treatment drug and some people get a placebo drug, and you're trying to determine whether the treatment drug works. And yes, people think very hard about the ethics of those tests. Um, there's actually a rule in medical tests that if you're doing a study, if you're in the middle of a study and it looks like it's obvious that the people getting a drug are either being helped or harmed, and you already know that conclusion, you have to stop the study in the middle. And if the drug helps, you get it to everybody as soon as possible. And if the drug hurts, you stop it. Um, I was actually part of a study like that on teaching methods when I was a graduate student. There was a test lab curriculum that I was implementing. I was teaching someone else's curriculum that they were studying, and I realized halfway through that the students were being harmed by this thing. And I said, I'm sorry, I can't keep doing this. The students are not learning what they should. Um, Ryan, could you outline what Joseph Mengele did? Christina mentions the Stanford Prison Experiment. Yeah, so places where you're having people kind of role play roles of a prison supervisor and a prisoner, and wound up doing like deep psychological harm to the people involved. Yeah, like taking people apart is often not a good idea. Um, Megan mentions tests that harm the environment, and the big example that comes to my mind is nuclear weapons testing, atmospheric nuclear weapons testing in the Marshall Islands, which did a huge amount of harm to places where the Marshallese live and destroyed some lovely natural features. Um, so here, these ideas are separate, right? You can do bad stuff and still do valid science, but you can also be honest and diligent and not trying to deceive anyone and make mistakes in the science process and come to incorrect conclusions. I've done this myself, right? As the notes say, I was in a hurry to get a result done in time for a big talk I was giving, and I made some mistakes, and I wasn't sufficiently skeptical of my own work to double check what I had done enough. And um, I wound up presenting some results that were not correct. And I had to go back later and say, I screwed up. So this is a thing that happens. Um, the other thing, when we talk about a flawed process of science, we're not talking about just plain old being wrong. Lots of us are wrong all the time because we write sine when we mean cosine or drop a minus sign. Um, we're not talking about just making these sorts of mistakes. We're talking about bypassing the safeguards that stop these mistakes from becoming conclusions we propagate to the world, or deliberately propagating nonsense to the world. Before we move on, like the reason we're doing this topic here, so this this component of this class is part of a broader movement in the physics department to talk about the process of science in our intro classes. And the reason is that it's going to be vital in our lives, your life, my life, that we as citizens of the world evaluate stuff other people are saying. And our world is very full of people who claim a scientific basis for things that don't actually have a scientific basis, either because they're misguided, because they have made mistakes, because they really ought to know better, or because, as is sadly too often, because they are trying to deceive other people. I don't think it's too strong of a word to call this bullshit. Our world is full of bullshit, right? And yes, I'm saying this on YouTube. And um, we need, as informed people, to be able to sniff out this sort of stuff when we encounter it. Um, and I'm not going to like take stances on controversial issues because that's not my place. But what I want to help you do is to give you the tools that you need to detect nonsense when you find it out in the world. Um, so we talked last week about four broad properties of science as a means of like figuring out what's true about our world. Empiricism means that science is concerned with measurements and observations and experiments as the ultimate arbiter of how the world works. You shouldn't just sit and think about it. It doesn't matter what you think should be true. You need to go actually measure it. The second one is that science is skeptical of itself. That if you're going to be making some scientific claim, oh, my mic did just get really quiet. Am I better now, Jacob? Yes. Sorry. I had taken my glasses off to clean them, and when I was doing this, I bumped my headset mic. I'm sorry about that. Thank you. And I didn't notice your comment right away because I had taken my glasses off to clean them and couldn't see. Um, I'll back up if no one can hear me. So, empiricism means that we are mostly concerned about measurements, the real world, as an arbiter of truth. Science is skeptical of itself because this is a safeguard against fooling other people, right? You should first make sure you haven't fooled yourself, and once you've made sure you haven't fooled yourself, then it's hard to fool other people. That was an argument put forth by Richard Feynman. Um, we recognize that the laws of nature are the same everywhere, and that they don't depend on our particular human perspective. We saw last time some guidelines for doing science well that stem from these principles. But what I want to do today is I want to talk about how they go wrong. Um, and we're going to look at a bunch of different examples of how these principles go wrong. But first, I want to kind of define a few terms here. So people like to use the word pseudoscience. Um, Pseudoscience is it kind of means people who believe they are being scientific, people who believe they are making well-founded claims about how the world works, but it's based on a deeply flawed application of the way science works. So an example would be many of the people who claim that the Earth is flat, the Flat Earth Society, who we're going to make fun of a lot in class. Um, Many of them really believe the Earth is flat, or they did, but they really ought to know better. Um, Another example is that in the early 1900s, um, the Polish-French scientist Marie Curie discovered the element radium, which is radioactive, more radioactive than any element that had been discovered so far. And there was a fad of people going around drinking radium, drinking other radioactive elements, because they thought that radioactivity is powerful and that if I drink this powerful substance, it will be good for my health. Right? We're all going to go drink radioactive stuff because it's good for us. And it doesn't actually work like Teenage Mutant Ninja Turtles. My whole childhood was a lie. Drinking radium, in fact, doesn't make you healthy. It makes holes show up in your bones and makes you die. Even, Marie Curie, who knew better, wound up dying of complications of a life's work with radiation. This is an example of pseudoscience. These people really ought to have known better. Yes, Nicholas, they were in for a big surprise. Um, Other examples. aliens making crop circles, ghosts talking through tape recorders, right? All of these things, the TV show Ancient Aliens. Um, the second category here is people being more nefarious. Someone making a claim who knows it's false, but are trying to support their deception by wrapping it in the language and trappings and appearance of honest science. So, what are some of your favorite examples of this kind of thing? What are some of your favorite examples of pseudoscience? Ghost shows, yeah. Um, Alchemy is a very interesting example because alchemy kind of predates the scientific process, but also extends into the scientific era. Isaac Newton was also like doing this weird alchemy stuff, even in the process of developing mechanics. If anybody has seen the TV show Newsroom, there is a character, written by Aaron Sorkin, who is an SU alumnus. There is a character who's always trying to convince the other people on the show that they ought to do a news story on Bigfoot. Uh, Dinosaur fakes. Uh, you went to high school with a person who claimed Mars was the original Earth, and we were what killed the dinosaurs when we landed on Mars. Uh, I don't even know how to write that succinctly. Uh, I'm just gonna say Dino baloney. Yeah. So yeah, big if true. Um, so I'd like to. What are some examples of the second category? So people who are making claims who they know are false, but they're trying to fool other people. Kahaku says politicians. I'm not even going to touch that one. Jacob, what were you going to say? Let's see, I can make you a presenter if you want to talk.
Yeah, I figured it would be easier to just speak rather than type
Sure.
it all out. But the researcher who started the whole calories is what makes people gain weight. Basically, what he did for presenting that research was picked the populations that he sampled that only supported that and that conclusion, and it ended up only being like 15% of the populations that he actually surveyed. But because they were the ones that supported the idea that more calories equals you're overweight, he only cited those,
Uh,
and
uh,
that led everybody thinking that that's how it is now.
that's a classic example of sampling bias, like you saw in your exam. Yeah, that's a great example. And the world of nutrition is full of stuff like that. Of people who want to sell some kind of diet and they come up with kind of phony scientific basis for whatever diet thing it is. um, the advice that I've heard given on diets is that eat not too much and mostly plants. Any other examples people would like to give? Thank you for that, Jacob. There are others. And then finally, well, the examples that I had here were the tobacco industry wanting to confuse people about whether smoking caused cancer so they could sell cigarettes for longer. That was a big deal back in the 60s and 70s. Scientific racism, in scare quotes, the people coming up with nonsense pseudoscientific justifications for their racism. That has been a huge problem. Um, yes, so this was used to justify eugenics in the first part of the 20th century, Zachary, of people doing, again, fraudulent science to claim that people of one race were genetically superior to people of another race, which is complete nonsense, and then using this to justify racism and eugenics. You know, yeah, that's how the world got into a whole lot of trouble in the first half of the 20th century, and in some places still does. Um, but also in this category are honest mistakes. Danelle, you see China's reported COVID-19 outbreak. Um, can you give me a little more detail by what you mean there? Um, oh, he's typing. Um, Separate from these are people who honestly make a mistake. An example that we talked about last time was the Army Air Corps in World War II was flying bombers over Nazi Germany to bomb the Nazis, and they were getting shot at, and they would come home with um, damage from shrapnel all over the place. And they said, okay, we're going to do a study on these bombers to figure out where they're getting hit, and then add armor to the locations where they're getting hit. And then they looked at, yes, this is survivor bias. Um, uh, yeah, Danelle, I'll come back to your example in a minute. They they looked at where these aircraft had their shrapnel damage, and they saw that it was all over the place, but not in the cockpit and not on the engines. So they said, let's add armor everywhere but the cockpit and the engines. And then a Hungarian statistician, who was himself a refugee from Nazi Germany, said, wait, don't do that. The reason that you don't have any airplanes that have holes in the engines and in the cockpit is because the airplanes that got shot there are splattered all over Western Europe because they got shot down, and the ones that you have that have damage, that's where you can hit an aircraft and it still fly. So you should add armor to the cockpits and the engines because those are the places where if you get hit, you get shot down. And I'm sort of glad of that because, my grandpa was on one of those airplanes. So maybe that's why he's alive. Um, so other examples people are talking about, and we can just like talk about examples. Like honestly, talking about examples is what I wanted to do today. Feel free to type out long stuff. Um, so Ryan mentioned that the airplane thing is an example of survivor bias, where um, you have a biased sample because it's only groups or members of a population that survived. We'll see another example of that later in this class. The Army Air Corps, of course, wasn't trying to deceive anyone. They were honestly trying to make their airplanes not get shot down, but they made a mistake. So there are different sorts of categories of culpability here. Other examples people mention. Danelle said accuracy in reporting COVID-19 numbers. You know, mentioned that some of that had happened in China, some of that may be happening in the U.S. In like how many people are actually contracting this disease. Um, that is kind of like straight up making stuff up. And one of the things that when you write your papers, if you choose an example that's kind of motivated by just straight up lying, um, or deception of that nature, then talk about how someone else would have recognized that something is wrong. The tagline of the recent and fantastic miniseries on the Chernobyl disaster, the tagline of it is what makes an RBMK reactor explode? Lies make it explode. And the show is about basically how the Soviet Union's attempt to, like, everybody kind of trying to cover their own butt resulted in this deeply flawed response to a troubled nuclear reactor. Um, Yet Leonardo mentions that there's been a lot of use of, in scare quotes, people from disfavored ethnic groups as medical test subjects. Um, the use of Puerto Ricans without their consent for these test subjects. My home state of Alabama has kind of a deep shame of the syphilis study being done on African Americans, and it's an enduring shame from my home state. Um, Christina and Ryan mention creationism. There's so I'm not going to touch this one with a 10-foot pole because I don't want to um, trample on people's religious faith. I will note that there are, honest, very capable scientists of all religions, but there is a lot of um, unfounded discussion about the injecting religious doctrine into, like, trying to color the scientific research of how old the Earth is and where it came from. Um, you can find lots of examples of that. And one thing I'll notice is these topics that I don't really want to wade into, like, because I don't want to impugn anyone's religious faith, they are still perfectly fine topics for your papers. You may talk about them, but I'm not going to, just because I don't want to tell anybody what to think about controversial issues. I want you to be equipped to make up your own minds about the controversies of today. But the point of this paper is for you to address controversial topics. So don't be shy about writing about, you know, COVID-19 or creationism or anti-vaxxers or climate change or any of these other things that are contemporary controversies. So what I want to do now is I want to look at ways that these principles get violated. You have already, been talking about your own examples. Please continue to talk about your own examples. And as I mentioned, I'm not going to be using as examples these contemporary controversies just because I don't want to be in the position of trying to, like, tell you all what to think. So what I'm going to do now is I'm going to kind of go through some common fallacies that bad science exhibits. Um, the first one is an ad hominem argument. So ad hominem means against the person, and this is saying that someone else is wrong because of who they are, not what they say. Um, Often this kind of crosses over into conspiracies, like people saying NASA faked the moon landings because their rockets didn't work and they still wanted to look like they won the space race, so they couldn't really land people on the moon, so they just faked it. So this is a false accusation of having an ulterior motive. Um, One of the, like, I kind of have to share this. I'm going to switch over to sharing a Chrome tab here. So smokingaloud.com, uh, about why all of the stuff about how smoking is hazardous to your health is really, just a conspiracy of political correctness. And, you know, like, they're talking about, okay, banning smoking, it's a wild public health feeding frenzy, and, you know, these sorts of sensationalistic things. Oh, right, here it is. The concern about the public health effect of smoking is all about dollar bills. And then if you scroll down a little more, oh, here it is, Nazis. So I don't know how we get from smoking will harm your health and other people's health to Nazis, but, here we're all about how basically the public health concern about smoking is really government trying to control your lives. Another false conspiratorial um, accusation of ulterior motives. So this whole website I find hilarious, but also deeply harmful. Um, all right, let's try to get my slides back. Another one, not as common now, but super common when my parents growing up, were that fluoridation of water to improve dental health. That's really just a communist plot. One that you also see is arguments based on status. So either saying we have to trust somebody because they're an expert, and I know when I was a kid growing up and watched TV, the whole like 4 out of 5 dentists say you should use this kind of toothpaste. Well, just because they're a dentist doesn't mean we should trust them. They should tell me why we should use that kind of toothpaste. But also criticizing people's ideas just because we don't like their race or their religion or their gender or their politics, or because they don't have um, credentials. Again, what you say should matter rather than who you are. Um, but another one are these arguments from authority. This is the opposite of an ad hominem attack, saying, "Oh well, more doctors smoke Camels, so obviously they must be the safe kind of cigarette, right?" This was a real ad, right? They were Camel was really running this ad, and what had happened was they mailed a bunch of doctors. They figured out some doctors that smoked and mailed them free Camel cigarettes. And then they came back in a few months and asked them what kind of cigarettes they smoked. And they said, well, I'm smoking the Camels you sent me in the mail. So, these were the surveys they had done. So sometimes, people really do have ulterior motives. They just wanted to sell cigarettes. So, what are some of your favorite examples of either ad hominem arguments or arguments from authority being used to support bogus claims? I'll give you all a moment to type here. One of my favorites was the New York Times commenting on spaceflight. In the 1920s, the New York Times wrote, after the rocket quits our air and really starts on its longer journey, its flight would be neither accelerated nor maintained by the explosions of the charges that it then might have left, meaning it burning rocket fuel. To claim that it would be is to deny a fundamental law of dynamics, and only Dr. Einstein and his chosen dozen, so few and fit, are licensed to do that. That Professor Goddard, with his chair in Clark College and the countenancing of the Smithsonian Institution, does not know the relation of action and reaction, and of the need to have something better than a vacuum against which to push, to say that would be absurd. Of course, he only seems to lack the knowledge ladled out daily in high schools. So here's some super snarky New York Times author who hasn't stopped to think about how a rocket works, that it's pushing against its own exhaust in 1920. But what they're doing is they're saying, here, Einstein is allowed to violate the laws of physics because Einstein is special. But this dude Goddard, who works for some college that nobody's heard of, he doesn't get to do that. This is a great example of argument from authority being contrasted with an ad hominem attack. Both of these are wrong. Einstein doesn't get to break the laws of physics, but some guy nobody's heard of is just as equipped to make scientific claims as anybody else. What matters is how does a rocket actually work? And is Goddard saying things that make sense? And the New York Times never looked at this. Um, of course, now we know that Goddard Space Flight Center is a thing, that Goddard was right. And in 1969, the New York Times, 3 days after people landed on the moon, wrote, Further investigation and experimentation have confirmed the findings of Isaac Newton in the 17th century, and it's now definitively established that rockets work in vacuum. The Times regrets the error, which is hilarious, but also kind of owning their own mistake. Um, some examples from you all. Uh, Jacob mentions that this is a common theme in political debates, candidates trying to build their campaign up and then eventually try to invalidate their opponent's claims based on who they are, not what those claims are. I know in the 1960s, in this era of spaceflight, there were people saying, don't vote for Kennedy, he's a Catholic. That's something my mother has told me about that she remembers from her childhood. People saying, don't vote for Kennedy just because of his religion. Um, so, what are some of your other examples? Kalhaku mentions ads for prescription pills on TV that claim they fix things, but the research is limited and incomplete. Yep. Politicians claiming cold weather means climate change is a hoax. Yes, this is an example of biased data. The fact that it snows sometimes in Syracuse doesn't mean climate change is not happening. Um, Jared's example, politicians denouncing the advice of a specialist in the field and base it on the idea that they're on the other side of the political spectrum, um, attacking them for their political beliefs rather than recognizing their ability in their field. Yeah, so saying that this, somebody who's making a scientific claim, oh, they're just, a member of an opposing political party. Um, Kate uses an example from literature, which is wonderful. So this is an example of a non-scientific ad hominem attack. So Hester Prynne is the protagonist in the novel The Scarlet Letter, um, and her being sort of attacked simply because of her reputation as someone who had sex outside of marriage. And the entire book is about um, that sort of thing. Christina mentions gendered products that can work for any gender, but the company sells two different kinds advertised toward men or women to make more money. Yeah. People call it the pink tax, right? A blue razor is the same as a pink razor, but the pink razor costs more because advertisers are trying to squeeze money out of women, and it's deeply unfair. Um, So yeah, examples of trying to hide harm done by DDT and other pollutants. Um, Arguments from authority based on religious texts as a high authority for scientific things. Um, Ryan mentions uh, climate change claims that are unfounded in the other direction too. Yes, there was a concern for a while about among some people about global cooling. Um, so yeah, the science of climate change is a very, very deep argument. Um, Alina mentions critiquing people's ability as a politician based on their looks. I don't want to get into, you know, judging politicians, but yes, like saying this person looks dodgy. Why would we trust them as a political leader? I think one of the great tragedies of American political history is that Franklin Roosevelt, the guy who beat both the Great Depression and the Nazis in some part, had to hide the fact that he had to use a wheelchair because he thought that people would not support him politically if they knew that he had a disability. And yet he was, by all accounts, a great political leader who served longer as president than anybody else and was president during the Great Depression and most of World War II. So yeah, there's a huge variety of paper topics lurking in the realm of ad hominem attacks, and you all have given me some great examples here. I want to now pivot to talking about dishonesty in statistics. So statistics is a way of taking a bunch of maybes and probablys and probably nots and unlikelies and I don't knows and turning them into an overall conclusion that something is almost certain. It is a super powerful field of mathematics, but it is subtle, it is hard. You can spend your entire career doing it. Um, and only somebody who's really familiar with a data set is going to be good at analyzing it. Um, there's an example of people who were doing studies on genetically modified corn in Hawaii, and someone else sued and said, "Give me your data. I want to reanalyze it for myself." It was studies on rats who were eating genetically modified corn. And they sued and asked for the data. And uh, the judge said, yes, if we're going to approve this for human consumption, then everybody ought to be able to analyze the data. But they weren't super familiar with the study, and they wound up making some mistakes in analyzing that data and came up with some like wildly incorrect conclusions about the health of these lab rats who were eating genetically modified corn, just because they made some statistics mistakes that came from not really understanding how that study went. Um, but statistics is completely essential if science is going to be empirical, right? The only way to get conclusions out of empirical data is by doing statistics. Um, a couple of ways this goes wrong. Um, this idea of garbage in, garbage out. Well, you have some data that are flawed and stinky, that are like blatantly biased. You do some statistical analysis that runs all of this through a laundry machine that says mathematics on the side, and then what comes out are false conclusions, but they're not stinky because we've hidden all the stinkiness and obvious bias behind a pile of mathematics. Um, one example is this idea that claiming correlation implies causation. So there's a famous argument made by the Discordians, or no, by the Flying Spaghetti Monsterists, kind of as a satire, that there are fewer pirates now than there used to be, and the climate is warmer than it used to be. So very clearly, the decline in pirates has caused climate change. Um, there are a variety of other sorts of statistical biases. We looked at p-hacking before, as an example of like playing with this idea of a 1 in 20 chance of being a fluke as some kind of threshold for significance. And I want to look at some others. So here is an example of how you do um, statistical inference in an honest way. This is a chart of, like, let's suppose you want to test a drug, to test to see if some drug improves the outcomes of people with heart disease. Let's take that as our example. So what you would do is you'd take your drug that you claim improves the outcomes of people with heart disease, and you would give it to a lot of people with heart disease, and you would compare it to a similar population of people with heart disease who are not getting the drug. And then you would look at the average of how people with heart disease do on this drug. And in your population of people who are not getting the drug, there's going to be a bell curve, a normal distribution, it's called in mathematics, of results. So on the left side of the curve, we have, I'll switch to red here. We'll say that this curve has the bad outcomes over here on the left and the good outcomes over here on the right. So this is what happens to patients without this drug. But if you observe that the outcome you get is over here, is to the right of the average, then, okay, maybe your drug actually helped these people, but maybe it was just a fluke. So what you can quantify is the probability that someone would have done this well or better by just statistical accident. And that's this green region, which I'm now shading in red over here. And the amount of that is It's called the p-value. It's the probability that this is a fluke. And if the measurement that you get when you give a drug to a patient, if you get over here, say, if this is the outcome you see with your drug, then it's quite unlikely it's a fluke. But if the outcome you see is here, then it's quite likely that whatever it is that you saw was a fluke. So what we do is we give the drug to many patients and we average. But there are some ways to do this dishonestly. The classic one is called cherry picking. It's just ignoring things that are boring or ignoring things that don't support your conclusion. So maybe the drug does nothing, but if you give it to everybody, you're going to see the entire range of results, right? You'll see the whole curve. But if you ignore the boring results that don't result in people getting better, or that don't agree with your conclusions, and you just kind of like chop off this piece of the distribution, all you're left with is something that looks like, on average, your drug cures people. But it doesn't. You just ignored the results that disagree with you because you have cherry picked examples that support your conclusion. Somebody gave an example of cherry picked nutrition advice earlier. Another example is survivorship bias. This is what Ryan mentioned is the cause of that example with the airplanes. So remember here, if we're studying a drug or studying an intervention with airplanes, remember some people over here with bad outcomes are going to die because of those outcomes. So if all of these people over here, do it this way, if all of these people over here are not in the sample because they're dead, right? Then what you're left with is something that looks like an average that has shifted to the right, that has shifted toward better outcomes because you weren't able to put the bad outcomes in your study because they have died. There's actually an example of this in contemporary times with the study of this claimed wonder drug, hydroxychloroquine, for COVID-19. There was a study that was done where they had given hydroxychloroquine to some people and then came back later and wanted to see if this drug reduced the amount of virus in their blood. But in that study, they detected this by doing a nasal swab, by sticking something up someone's nose and seeing how much virus it had adhered to it. It was part of that culture. But you can't stick something up someone's nose if they are on a breathing tube or if they are dead. So their study, it wasn't survivorship bias, but it was a study biased toward a sample of patients that were not on ventilators, and those are the sickest patients. So this has happened in the contemporary era as well. Another example is publication bias. This is the one that you saw in the jelly bean example from last time, right? If lots of people do studies, suppose a drug doesn't work, but lots of people do studies, some of them will see a slight positive effect, some of them will see a slight negative effect. A few may see a big positive effect. It's still just an accident, right? They're still on this bell curve of things that would happen even if the drug did nothing. But if these are the exciting ones are the only ones that get published in medical journals, then the community as a whole gets a flawed conclusion, right? And this can be really insidious because there is career pressure on scientists to publish exciting things, right? Nobody wants to publish a story that publish a study that says, "Yep, we tried this, it didn't work." Like that's not a thing to build a career on. But publishing studies that say we tried this, it didn't work, are vital to correct conclusions. Um, oh, Ryan says so EOD is explosive ordnance disposal. I believe that's the right acronym. Ryan worked as someone who diffused bombs in the military. And he says that they had their own version of the survivor bias. We got new versions of the protective suit, and a couple of guys got blown up in them, which made the old timers start to say that the old suits were better. They would come up with all these reasons why the old ones were superior to the new ones. No data supported their claims. It was just bad luck. Um, you know, I, so Ryan, you didn't talk explicitly about survivor bias there. I mean, kind of what my interpretation, my reading of this is that, okay, maybe some people got blown up in the old suits too, but they weren't around to talk about how they got blown up. Is that possibly something that could have happened? Yeah. So this is like an insidious thing that people have to be on guard on. And again, no one's trying to be deceptive, right? Nobody wants to get blown up. But this is people making honest mistakes. Um, the reasoning was that the new one had less vision. Yeah, this is actually my PhD advisor, who is very good at statistics, said to me he had gotten a new Jeep, and the new Jeep had side curtain airbags, and they came in like big pylons on the side of the windows. And he was musing, am I more likely to have my life saved by this airbag, or am I more likely to drive off the side of a mountain because I can't see because this pylon is in my way where the airbag survives or where the airbag exists? And, you know, he's still alive, so he hasn't driven off a mountain yet. Um, the next thing I want to pivot to is the common fallacy of ignoring refuting evidence. So, being skeptical of your own conclusions is a hallmark of science done well. Good scientists have to look for ways that they might be wrong and quantify how they are uncertain about their result. Um, all of this really complicated figure here is me working super hard in my PhD thesis to calculate just how uncertain I am about the result I have gotten. There's kind of a general rule in science that good scientific writing spends a lot of time talking about the limits of its knowledge. So anybody who's trying to talk up their results, trying to talk up their confidence, rather than look at it in an honest, sober way, you should question that. Um, a very common example of faulty science or science gone wrong is failing to search for refuting evidence or ignoring obvious refuting evidence. Um, does anybody have any great examples of this they would like to talk about? Well, you all are typing your examples of um, faulty science that has ignored or failed to search for potentially refuting evidence. I'd like to give my favorite example. I'm loading the Flat Earth Wiki. Um, Again, anti-vaxxers. Could you give a little more detail, Marcia? Well, I'm getting up my Chrome tab here. While Marcia is typing. Um, yeah, so this is a map of the flat Earth that flat earthers are claiming is really the how the map works. And this map maybe correctly tells you how to get from uh, New York to Spain and tells you the distance from New York to Spain. But if you go down and you measure the distance from Argentina to South Africa to New Zealand, you're going to be wildly wrong with this map. Never mind the fact that you can actually like cross Antarctica. Um, and people have done these things. So the flat earthers have just completely ignored the experience of a whole lot of people in the southern hemisphere. This is another example of failure of objectivity, right? This was pretty clearly drawn by people from the northern hemisphere. But the science that you do shouldn't depend on where you're from or what your biases are, what your background and experiences are. Um, all right, so here are the yes. So Marcia says yes, the anti-vaxxers ignoring um, lots of experience that the world has with vaccinations. Yeah, vaccinations have been well tested and used for quite a while. Uh, Ryan mentions an experiment done. Um, so when you say drift, Ryan, drift in what? Um, you mean drift in? Oh, flatten the curve. This is the flat earther thing. Yeah. So often people just kind of wave their hands. They dismiss potentially refuting evidence with a wave of the hand without actually engaging with it. That's pretty common among moon hoaxers too. Um, uh, yeah. So Kate mentions climate change is a hoax, despite evidence that the Earth is warmer. Um, Yeah. So Ryan mentions it was pretty incredible to just watch this. I need to watch this. Apparently, it's hilarious. Yeah. Max says I've shown a projection from the North Pole. You can also do this from the South Pole, but the flat earthers never use it. Well, um, there aren't that many flat earthers from Argentina or South Africa, I guess. Yeah. Even though the flat earthers did say, there's some quote from some of them saying, "We have supporters from all around the globe." Yeah, why don't you sit down and think about what you just said, dude? Um, I'm going to, well, I'll talk about this briefly. So, another way that this happens is ignoring all of the claims made by the rest of science, right? The laws of physics are the same everywhere. They've been the same, since the beginning. So this means that if you have a new idea, it doesn't just have to agree with whatever you measured. It's got to agree with every bit of empirical data from the beginning. Um, So an example is that when people started investigating nuclear physics, they saw reactions that seemed to violate the conservation of momentum. But what does that mean? Well, either we could throw out the conservation of momentum or we could think very hard about nuclear reactions. And there's so much data supporting the conservation of momentum that people said, yeah, we can't discard the conservation of momentum. What had happened was um, there were invisible particles that are very hard to detect, um, very hard to detect particles that they missed. These are called neutrinos. They've since been observed. Um, a great example of this is the EM drive. There were people who had claimed to have invented um, a way to propel a spacecraft that was like a rocket but didn't actually use any fuel. It just needed energy. And they said, yeah, this appears to violate the conservation of momentum. After the exam, Newton's third law and the conservation of momentum are related. They couldn't explain how it really did work, but they said that it did. So people making outlandish claims, need to have a proposal for how this thing is at least compatible with all of the things that we have measured over centuries. it turns out that if you put a whole bunch of very intense microwaves in a box and claim it's a rocket, all of those very intense microwaves will also mess up your measuring equipment. Um, they tried to do this well, but they shielded it as well as they could. But the mistake they made was in not being sufficiently skeptical of something that seems to violate 300 years of experience. The last thing I want to talk about is a manufactured controversy, and this is a big one. um, so often people try to advance scientific claims negligently or dishonestly. You all have given lots of examples here. But sometimes people who are dishonest, sometimes the peddlers of nonsense, aren't trying to convince us of something they know to be false. All they're trying to do is get us to reject something that's really true. Um, if you believe something and your belief in that thing, if you believe something that's true and your belief in that true thing hurts me, either financially or politically, I don't have to convince you of something else, right? I just have to convince you to have unfounded doubts in the true thing that you believe. And this is commonly done by making up a controversy. Um, we see it not just in science, we see it in politics, we see it in negative advertising. If I'm trying to sell Coke, maybe I don't have to convince people to buy Coke, I just have to convince them to not buy Pepsi. If I'm trying to sell you a car of one brand and there's only one other brand of car, all I've got to do is convince you that that other brand of car is not safe. Um, do you all have any favorite examples of places where people have manufactured a controversy where there really isn't one? While you're typing in chat to save time, I'd like to talk about my favorite, which is the tobacco industry. Research started coming out in the 1950s and 1960s that smoking was really bad for you, that smoking cigarettes would damage your lungs, that it would cause lung cancer, and that it would shorten your life. And the tobacco industry, again, they do, cigarettes are addictive, right? Quitting smoking is hard. And they didn't need to convince people that smoking was safe. All they needed to do was to convince people that smoking wasn't unsafe. So they took these studies about the dangers of secondhand smoke and they said, yeah, it's not really secondhand smoke. Maybe it's like mold in your building. Maybe it's poor ventilation. Maybe it's bad air. And that's a much easier sell. Um, so some examples people have here. Uh, so Gilberto mentions the feud between Tesla and Edison, which is a great topic. Um, Edison did some like really crazy things to convince people that um, Tesla's proposal for electricity was unsafe. Like that got real nasty, and we do not have time to dive into that whole thing. But if you want to write your papers about the Tesla Edison controversy, go for it. Giachi mentions, yes, the sugar industry trying to stir up a controversy about whether eating fat or eating sugar causes obesity. Yeah. Um, here's a quote from an article from the Bulletin of the World Health Organization on the way that the tobacco industry convinces people to continue to smoke. Christina mentions diet soda. Yeah, that's a good one. Um, so the tobacco industry. So here's the World Health Organization. The industry's strategy does not require winning the debates it manufactures. It is enough to foster and perpetuate the illusion of controversy in order to muddy the waters around scientific findings that threaten the industry. Thus, it offers reassurance to smokers, helping them to rationalize and repress their health concerns. Furthermore, claims of not proven resonate with friendly or naive journalists and governments, and provide an excuse for not taking strong governmental or societal action against tobacco. So they're pointing out that the tobacco industry um, just tried to muddy the waters around the scientific consensus that smoking was harmful to your health to reassure smokers and then governments that they were slipping money to. Yes, Alina mentions HIV AIDS denial, which was a terrible, terrible thing. I was not, I was not really old enough to appreciate just how criminal what the U.S. government, frankly, was doing in the 1980s that led to the deaths of thousands upon thousands of people. And again, this goes back to objectivity because the people who were dying were of a disfavored sexuality. And it was a really, really bad thing in the 1980s. Um, and has continued in other manifestations in other parts of the world. So the last thing. So let's see. I do want to talk about this last thing. Sensationalism, finally, is a violation of this duty to be skeptical of yourself. Um, a lot of scientific findings are really exciting, right? Science is super cool. I'm going to come back to the slides that I have about that black hole picture because they're super cool. We're not going to do it today. We'll do it, later in the class. Or you could look at those slides and see what's coming. But whether something is true is not connected to whether it's exciting. There are a lot of very exciting things like the potential of drinking silver curing COVID-19, which is not true. Um, and that excitement has nothing to do with its validity. So scientists kind of have two duties that go hand in hand. Science is very exciting, and the public ought to share in that excitement, right? So it's a duty that scientists have to share the exciting things in our field with the public. The astronomers are very, very good at this, like the black hole folks. Physicists need to get better at it. But the excitement behind something is separate from evaluating whether it's true or not. And you can always recognize that it's a dangerous thing when someone trying to convince you that something is true instead tries to convince you only that it's exciting. So if you see a bunch of hype and somehow that hype substitutes for sober analysis, that's kind of a clue that something is screwy. So here we've talked about a bunch of your examples and we've run a bit over time. I've got 2 minutes left and I want to talk about the paper. So we will come to black holes another time. So I'm going to stop sharing my slides. If you have any questions, please feel free to type them as I get my website up. So if you go to the course website, which I'm sharing right now, whoops. Boop. You'll notice that there's a new link for the process of science paper. There's also a link up top. This explains in thorough detail what you should write. But this paper is very open-ended. You may choose all kinds of different topics. And in recitation tomorrow and for your next homework, we want you to brainstorm and propose a topic to us. If you have any questions about what the paper should be, what it could be, if you have something cool you want to talk about, please drop me a line, shoot me an email, contact me on Discord, talk to your recitation TAs tomorrow, and we will help you turn your proposed topic into a great paper. If you have any questions, please ask us. I've got something in chat. So it's 10:50. Anybody who wants to head out can. Let me answer Danelle's question because this is actually super exciting. Danelle asks, isn't quantum mechanics incompatible with general relativity? How does that fit in with theories having to be aligned with already established universal laws of physics? This is a really good point. It's not that it's incompatible. It's that no one knows how to make it compatible yet. Because the mathematics that we use to describe general relativity, we do not know how to combine those mathematics with the mathematics we use to describe quantum mechanics in a way that allows us to solve the equations. People have proposed various ways of doing this, um, but one of them I am actually working on right now. I'm not really the lead person on this. I'm helping someone else because I'm a computer simulations guy. And this guy has an idea of how to do this with a computer simulation and maybe understand quantum mechanics and general relativity playing nice together, not as equations that you solve with a pencil, but numbers that are crunched by a computer. And so if you've been into my office, you'll see that I have a really fancy computer that looks like a gaming computer on my desk. That computer I built for Professor Jack Lyho, who is working on this right now. And that computer is running his computer code, um, crunching numbers to try to figure out if a way that quantum mechanics might be compatible with general relativity. So it's not that they're incompatible, it's just that the problem hasn't been solved yet, and somebody in our department has a good idea maybe for how to do it. And if you'd like to talk more after class, Danelle, about how that idea works, I would be happy to talk to you about that. Are there any other questions from folks? Where can you go for your lab period? I don't know, Nicholas, because I'm not involved in the lab. You could email uh, Sam Sempier, or you could message the lab help channel on the class Discord server, and someone might be able to help you there. But I just legit don't know about the lab. Samuel, I've seen that. Um, I am so sorry about your internet. I unfortunately, like, if you're in Syracuse, I might be able to help you. If you're not in Syracuse, I may be able to help you a little bit, but unfortunately, like, fixing Wi-Fi is not something I can do remotely. But yeah, I'm super sorry about that. The recording will be on YouTube, so you can grab it there. Yeah, thanks, Samuel.